22% chance that we have exactly 3 customers come to our kiosk, given that we expect 3. Now, here's a question. What could we do if we wanted to see the probability that greater than 2, more than 2 customers arrive? So instead of exactly, here I change this and I change it to more than 2 customers arrive. I don't want less than the average. I want more than 2 customers. I want 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10 or 11 or 12 or 13 or 4. Wait a second. Do you see what I'm going? 15, 17, 18, 19, 20, 21, 20. Do we want to do all these calculations? No. In fact, we want to work on simplifying it. So think, if I want to do more than 2, the probability of more than 2 has to be 1 minus the probability of 2 or less. 2 or less is easier than doing more than 2. I can do the probability of 2 plus the probability of 1 plus the probability of 0. Okay, so that's the probability of less than 2. If I just subtract it from 100, I get the probability of greater than 2. So let's draw that out. So the probability of greater than 2 is equal to the probability that x equals 3 plus probability x equals 4 plus ... probability x equals infinity. Now this goes back to a long way. That's a lot of computations that we don't want to do. We can simplify this out to say that the probability that x is greater than 2 is equal to 1 minus the probability that x is less than or equal to 2. Okay? Take a second and think about that. Did I get it right? So, if I find out the probability that x is less than or equal to 2, then I can just subtract from 1. So this is equal to the probability x is equal to 2 plus the probability